Hi guys, in this video I wanted to go over inequalities and how to represent line graphs. So just a quick review on inequalities. Usually an equation will look like this, or most of the ones that you've come across. Maybe it's x equals 5 plus y or something like that, right? While an inequality will be x is greater than 5 plus y. So this means greater than because that's the sign that they use. X would be greater than 5 plus y, or if you did this, x would be less than 5 plus y. And if you did this, where you draw a line underneath, you would have x is less than or equal to 5 plus y. So, yeah. So, you don't get a definite answer from this. You just get sort of a set of values. So, for example, if we said x has to be less than 5, okay? X could be anything. It could be 4.99999. It could be x equals 4. X could be like negative 100. Anything less than 5. So it gives sort of like an area where x can be. Okay. So now we're going to talk about how to express those on graphs. So let's just start with the simple one. So let's say y has to be greater than 5. Okay. So y just has to be bigger than a constant, and we can show this on our graph. So this would be 0, right? And we know that y, which is the y-axis, always has to be more than 5. So if we were to draw a line at 5, and we'll say this is value 5, then y would be able to be anywhere in this region. It would always have to be above 5, okay? So it would always have to be greater than 5. It couldn't be over here, but it could be anywhere above. It could be up here, anywhere around there. Now, if we wanted to incorporate x in the inequality, so let's say y has to be greater than or equal to x minus 2, okay? Then what y could be at every individual x value would change. So if you don't understand what that means, don't worry. So let's say at 0, x is 0. Then y would have to be greater than or equal to negative 2. So y at this particular point could be anywhere here, okay? Now let's say x is 1. So at 1 would be 1 minus 2, which would be negative 1. Okay? So then y could be anywhere here. Now at at positive 2, where x is 2, then it would be 0. So we have a line like this. You can kind of see there's a pattern, and there's a line like this. So y could always has to be above this line, okay? Or equal to the line. So when x is incorporated, that means that y at those individual x points has to be greater than it. So at 0, it could be anywhere along this line, this individual sort of segment you can imagine. But at 1, it could be anywhere around here. And then at 2, it could be anywhere around here. So the region in which y can be actually changes based on what x is. Sorry about the line. But that happened. So as x changes, the region where y can be also changes. So let's try something else. Just for practice. Let's say y has to be less than or equal to x minus 2 squared. Okay, let's draw this out. Okay, so let's start at 0. 0 minus 2 is negative 2. Okay, negative 2 squared is going to be positive 4. So we have positive 4. Now if we go to 1, 1 minus 2, negative 1 squared will get you 1. And then 2, it'll be 0 squared, which is 0. So it will give you a parabola if you were to grab it. And we know this from Math 11, the past Math 11, the parabolas. I'm pretty sure I have videos on that. So anyways, but this is going to be our parabola, okay? This is what x minus 2 squared looks like, okay? Now, y has to be less than or equal to this equation, okay? So this graph here, with just this line, this line is basically y equals x minus 2 squared, okay? It's basically like saying, or like f of x, if you're more familiar with that. F of x equals x minus 2 squared. So it's just a normal equation, right? We've done this before, okay? But now what we're saying is that y has to be less than or equal to x minus 2 squared. So y is given a little bit more leeway in where it can be. So that means that y can either equal this, which is basically just y equals this, or it can be less than it. So it can be anywhere down here, and I'm going to shade it in. It can be anywhere below this. It can be anywhere below. Okay? So it's similar to y equals x minus 2 squared, as it can also be on this line, but it can also be anywhere below it. So it has a much greater region where it can be. That pretty much wraps up inequalities on graphs. This works for more than just parabolas, you know. It can be linear, it can be quadratic, it can be any sort of function. But that is basically the gist of it. And when you have inequalities, you have to think, so y can be less than or equal to x minus 2 squared. So it's basically like comparing your y value to when y equals x minus 2 squared. So it's like graphing x minus 2 squared, and then you're saying that y can be less than or equal to that. So it has to be in the region below. Or in the case that it was greater than or equal, or just greater than, we could say it can be anywhere in the region above. So that pretty much concludes it. Thank you.